Hello friends, in this video we are talking about the force on current carrying conductor. Okay, what the thing is. See, whenever a current carrying wire is placed inside an external magnetic field, then that current carrying wire will experience some force. In class 10th, you are not supposed to find the value of that force, but you are supposed to find only the direction of that force. What is this? Suppose that I have this magnetic field, okay, represented by dots. This is the magnetic field, and from this magnetic field a current carrying wire is passed. Then there will be some force that is applied on this current carrying wire. That force can be outside, inside, this way, that way, left, right, or in any of the directions. Such a force is known by the name of Lorentz force. What do we call it? Lorentz force. Okay, and what we are studying now, that is the force on current carrying conductor inside an external magnetic field. Right? So, which rule is used to find the direction of that force? That is Flh rule or Fleming's left hand rule. Right. What that rule is? Very simple. You have to take the fingers of your left hand. Now this is not my left hand, this is Fleming's left hand, and you have to place the fingers, you have to keep the fingers first like this, the thumb, the first finger and the second finger. Be very cautious when you are keeping them in this manner. It should not be like this, it should be exactly like this. The hands, the fingers should be comfortable. Thumb, first finger, second finger. And the order which they represent is force, field and current. What is that? Force, field and current. Right. That means if you keep your first finger in direction of magnetic field, the second finger in the direction of current, then the thumb will show the direction of force. Clear? Let us do some very simple examples on this. First example, the magnetic field is represented by the arrows. It is going from left to right. This is conductor number 1 and it carries electric current in upward direction. So, first two fingers, first finger in the direction of magnetic field. See, I have kept my first finger in direction of magnetic field. The second finger is in upward direction, and then extend your thumb. The thumb is showing which direction? It is showing inward direction. So the direction of force on this conductor will be inside. Now in the second wire, I have changed the direction of current. Keep the first finger in the direction of magnetic field, the second finger in the direction of current, that is downwards. Okay, magnetic field, current, and the thumb will show you the direction of force. What is direction of force on this wire? It is outside. Okay, this simple is the rule to find the direction of force. Of course, we do not find the value of force, but let me tell you that on what factors the value of that force will depend on. Firstly, it depends on the magnetic field. If your magnetic field is stronger, then the force will be stronger. Then it depends on electric current. More will be the current, more will be the force experienced by it. अगर मैं यहाँ पे current को double कर देता हूँ, then the force will also get doubled. The third thing on which it depends is on the length of the wire. Okay, greater is the length of this wire, greater will be the force acting on it. All right, so this was Fleming's left hand rule. Few more examples of Fleming's left hand rule. I have the magnetic field like this. So the magnetic field represented by B, it is in upward direction, and I have currents. This is current number 1. I call it current I1. The direction of force on this current. Keep the first finger in direction of magnetic field, upwards. Keep the second finger in direction of current, like this. And the thumb will show the direction of magnetic field, that is outwards. Similarly, if I reverse the direction of current, I2, the direction of force is also going to change. Field, current and force. Force will be where? Force will be inside. Okay. Now, if suppose the magnetic field is represented by dots, okay? Remember this thing, you have seen trains and the front of the train, you see a big dot, okay? And at the last bogie of the train, you see a cross sign. Train की last bogie के ऊपर cross sign होता है. So whenever you are seeing the dot of the train is coming towards you, that is outside. And whenever you see cross, the train is moving away from you, and here it is inside. ये आपके पास में आ रहा है, so it is outside. Cross आपसे दूर जा रहा है. So here the magnetic field is represented by the dots. That means magnetic field is in which direction? It is in outward direction, right? And there is a proton, a positively charged particle, which is moving from left to right. That means the current is also moving from left to right. What is the direction of force? Field, this is the direction of field outside, this is the direction of current, that is this, and this will be the direction of force. That means this proton is going to experience a force in which direction? In the downward direction. Now again, instead of proton, if I am having electron is having negative sign, what will be the direction of current? If electron moves like this, the direction of electric current is opposite to it. That means this is the direction of electric current. Again, do the same thing. The first finger in direction of magnetic field, that is outwards. The second finger in direction of current, that is towards me. And the thumb shows the direction of force, that is in upward direction. So this is the direction of force on the electron. This rule not only helps us to know the direction of force, but based on this rule, many different devices were made, like AC motor and DC motor, which we will be learning in the next videos.